This video will cover problems from section 4.2, applications of exponential functions. I'm going to start with problem number 3, and it says, when money is placed in a bank account that pays compound interest, the amount in the account grows exponentially. Suppose such an account grows from $1,000 to $1,316 in 7 years. Find a growth function of the form f of t equals y sub 0 times b to the power t. That gives the amount in the account at time t years. So for this problem, we're not given the equation. We're actually going to have to find it ourselves. So we're going to use the information that is given here. And I know at first it looks like they're not giving us much to work with, but they actually are. And so here it says that an account grew from 1,000 to 1,316. So right here, and remember we're going to use t to represent years, and that is our independent variable, so we're not going to be using x. So I'm going to say that at t equals 0, the initial value was 1,000. So we could say that this one is going to be equal to the y sub 0, the initial amount. Now after 7 years, so at t equals 7, we're going to have 1,316. And this will happen at t equals 7. So what I'm going to do now is use this information given to us, 1,000, and I'm going to substitute it into my model that I have here. So that y sub 0 is going to be changed with 1,000. So the function is going to look like this. F of t is equal to 1,000 times b to the power t. Now, we don't really know what b is equal to, the base. However, we can find it because we have another piece of information. So the information that we have here is we are going to substitute the t with the exponent with a 7. And then the output is going to be substituted with 1,316. Because what they're telling us here is something similar to this. F of 7 is equal to 1,316. So I'm going to go ahead and do that here. So instead of f of 7, I'm going to put 1,316. This will be the exact same thing. And here for t, we're going to use 7. Now this is going to be solved by, first, we're going to take the 1,316 and divide it by 1,000, because 1,000 is multiplying here. So once we take it to the left, it's going to change to its inverse operation, which is division. So then here we're going to have b to the power 7. Now if we perform this division that we have here, it's similar to moving the decimal point 3 units to the left because we are dividing. So this will be 1.316 equals b to the power 7. Now, how can we undo an exponent of a power 7? Well, think how you will undo a square, and you will tell me right away, I take the square root. And yes, those two are inverse operations. So yes, there is such thing as the 7th root. And I'm going to show you how to enter it on your calculator in a minute. But just from here, let's know that the power 7 is going to cancel. So then b is going to equal to the 7th root of 1.316. So I'm going to go ahead and go to my calculator. And I actually have something here that I'm going to use in a minute. So let's add a page. And so we could put it in parentheses. In fact, you can take, if you have a calculator like mine, you can take just the 7th root, change the index, and then type in your number there, which is 1.3, I forgot what the number was, 1.316. And if I press enter, it gives me that decimal approximation. Now, if you don't have that option, you could always use parentheses, enter the number inside the root, close your parentheses, and then raise that number to the power 1/7. And that will give us the same answer. So the answer is 1.04. So in this case, the value for b, the base, is going to be 1.04. Now let's review this quickly. Since the base is bigger than 1, it's going to be exponential growth. Now our equation that used to be this, now it turns into f of t will equal, in fact, it used to be this one originally. So first we changed the y sub 0, the initial amount, to 1,000. And now instead of b, I'm going to enter the number that we found right here, 1.04, and that is what's going to be raised to the power t. So I'm going to erase this for a minute. So that would be our new model. Now that we have that model, we are able to answer any question. So the question says here, how much is in the account after 12 years? And if you notice, we're not really concerned about what year it is. We just want to know what happened after 12 years from the time the initial amount was deposited. So what we're trying to do is find f of 12. And so we will substitute it like this, and to the power 12. Now to enter it on your calculator, you could enter 1,000, and then you will open parentheses, enter the numbers 1.04, exponent symbol, and then 12. And then of course press enter or control enter if you want an approximation. And so you should get something that it is approximately, and since we're talking about money, we're going to round to the nearest cent, 1,601 with 3 cents. It's not a 6, sorry. 0, 3. And so that would be the answer to our first problem. So just as a quick recap, first we had to find the equation. We started from here. Then we replaced y sub 0 with 1,000. Then we used the fact that we had some information, so we replace our f of t with this number, and we replace our exponent with a 7. And then after that, we went ahead and solved for b by first dividing by 1,000, and then by taking the 7th root. And with that, we got that the value of the base was 1.04. So now let's move on to the next problem. And this problem here is representing the infant mortality rates in the United States. And so in this case, we're letting t equal 0, 1920, the year 1920. And we're going to use the model that we have here, and it's similar to the previous question, to create our own equation. But we're also going to use exponential regression on a graphing calculator. Or in this case, I'm going to use a website to find the model for it. So if we look at this part of the table, it's giving us something similar as what we had on the previous problem. So for t equals 0, the output, the f of 0, is going to equal to